Distillation is a technique used to separate a mixture of two liquids by leveraging the separation in boiling point between the two liquids. In this lab, you will be doing both a simple and a fractional distillation. In a simple distillation, the two liquids in the mixture have boiling points separated by 40 degrees Celsius or more. In a fractional distillation, the two liquids in the mixture have boiling points separated by 25 degrees Celsius or less.
Okay, so we're going to be doing a simple distillation today, and this is all of the glassware and all of the other materials that you're going to need for this lab. We have the hexanes and the toluene right here, which you're going to be using. This is the pasture pipette and the bulb that will go on top of it. And here we have a spin vane, which will go inside of your conical vial. These are O-rings, and these are screw caps that will be placed on your glassware in order to connect them. This is a Clayson head and a Hickman still, and you need to make sure that it has this little cap on there. This is just a little vial that we're going to be collecting stuff with, and then this is a graduated cylinder.
Okay, we're going to make our solution for our distillation, and you're going to take 1 milliliter of toluene and add it to your graduated cylinder. Then you're going to take 1 milliliter of your hexanes and add it to the same graduated cylinder to make a total of 2 milliliters of solution. Okay, now you're going to take your 2 milliliter solution and add it to your conical vial. Okay, once it's added, you can take your spin vane and drop it inside.
So now we have our apparatus set up. This is our Clayson head and our Hickman still and our conical vial with our spin vane in there. Now we're going to turn on our stir, just lightly stirring, not too much, and then we're also going to turn on our heat, and you can turn it on to about 4 and then go from there. And we also want to make sure that our conical vial is touching the hot plate so that heat can transfer.
So as this is refluxing, we want to make sure that sometimes if it's too hot, bubbles can start appearing up in the conical vial and up in this neck right here. And we want to make sure that doesn't happen, because if bubbling over happens, we can contaminate the pure hexane with toluene and we can mess up our product. So as this is heating up, we want to make sure that no bubbles appear up in here. If there is, just turn down the heat and hopefully they go away. Okay. So now we've had some of our solution collect here in the Hickman still, and to get it out, you're going to want to unscrew this side cap right here, exposing it right here. And this is hexane that's collected because it has a lower boiling point than the toluene, and so we want to collect this almost as soon as it starts to show up, because the longer we let it sit, the less likely that it will be pure hexane, because toluene will start to evaporate and condense onto the sides. And so once you collect it in your pasture pipette, you put it into this vial and you go in again, get as much as you can, because this is what we're going to put in to the IR later on. And so we know we're pretty much done now, because we have about 1 ml left of solution. And so at this point, hopefully that's all just toluene, and we can turn this off. Turn off your stir, turn off your heat, and let this settle, and then we can screw this off and this is our pure toluene, and in our vial is our pure hexane.
And now we're going to be doing a fractional distillation. Everything is the same for a simple distillation, except now we're going to be adding in our reflux condenser and steel wool, which will go inside of your reflux condenser. So now we're going to be setting up our fractional distillation. After doing your simple distillation, you don't want to clean your glassware with water or acetone, or else that'll mess up your product. So you're going to take some steel sponge and you're going to put it into your reflux condenser. You don't need a lot of this, because if you have too much, then your vapor can get trapped in your steel sponge. So you don't need a lot, just a little bit. And so now you're going to push this in here. And the reason that we are putting the steel sponge into the reflux condenser is because it allows more surface area for the solution to interact. So then that way you can get a better distillation of your solution. So we have our steel sponge and our reflux condenser like this, and you're good. So we have our fractional distillation apparatus set up now. Up here we have our Clayson head, and then our Hickman still, and then the reflux condenser, and finally our conical vial with our 1 mil hexane and 1 mil toluene and our spin vane in there. And so we're going to do the same thing we did with our simple distillation, turn on our spin vane, stir, and then we're going to turn on our heat as well to about 4 or 5. And we want to also make sure that our conical vial is touching our hot plate. So now, just like with our simple distillation, we're going to collect our distillate in the, whatever you want to call this, the circle of the Hickman still. And again, this is going to be hopefully pure hexane. And we're just going to deposit it into our vial. You want to get as much as possible, so that way you don't have any mixture with your toluene. Looks like that's as much as we're going to get.
Now we're going to show you how to take a sample on the refractometer. So you're going to open up this prism, and you're going to put your sample on the base of the prism. Just a couple drops will do. Then you're going to close the prism, and in the front of the refractometer you're going to turn on the light and bring the base of the light until it touches the prism. Now you're ready to look through the eyepiece.
While looking through the eyepiece, adjust the focus knob until the horizon is directly on the X.
This is what you should see when you first look into the refractometer. Notice how the horizon is not lined up with the cross of the X. Be sure to adjust your refractometer so the cross of the X and the horizon line up. If you need help adjusting or cannot find your horizon, your lab TA or instructor can help you.
Once you have the horizon lined up, press Read.
Okay, so in order to figure out your percent hexane in the samples that you took from your distillation, you're going to open up Excel and you're going to plot these two data points right here. For toluene, and you get this from your lab report, toluene, it has a 1.496 refractive index and obviously has 0% hexane. And then with hexane, it has a 1.375 refractive index and it's 100% hexane. And then you graph those 2 points, put them into a chart. So here we have our hexane point, here we have our pure toluene point, and then you fit a line to that and you get this equation up here. And so what you're going to do is, once you get your refractive index values from your refractometer readings, you're going to plug that value in for Y and solve for X. X is going to tell you the percent hexane that is in your sample. And you run that for both of your distillates, both of your separated distillates, and you can get how much percent, how pure your sample was based off of the actual pure samples of hexane and toluene.
Either before or after you use the refractometer, make sure you get an IR of both your hexane and toluene samples. Gathering multiple forms of data allows you to be more confident that your product is pure. If you forgot how to take an IR, the instructions are right next to the machine.